Most people live their lives believing that they know the world around them well, that the greatest achievements of humanity are visible, within sight. But beneath the silent soil of a land known for prairies and summer storms, something gigantic is taking shape, and almost no one knows about it. What is being built there is not just a project, it is a plunge into the abyss of existence, a project that will traverse miles of solid rock involving engineers, scientists, and workers in a race against time, the unknown, and the very limits of human understanding. A construction that, when completed, will be the deepest, widest, and most advanced scientific underground structure ever built by man. Imagine caverns the size of cathedrals, buried more than a kilometer underground. Imagine 4 gigantic lakes, not of water, but of a clear and dangerously cold liquid, called liquid argon, kept at almost minus 186 degrees Celsius. Now imagine that all of this is being created to try to answer a single question. Why is there something rather than nothing? The scale of the project is staggering. There are over 1,300 kilometers of planned structure, a network of tunnels and secret chambers connecting different states beneath the Earth's crust, all designed with a clear and almost poetic purpose: to capture particles that pass through everything and leave no trace. Particles that perhaps, just perhaps, contain the answer to the greatest mystery of the universe. This is not a science fiction story. All of this is happening now. As you watch this video, machines are excavating the ancient rock of a forgotten mine. Scientists are calibrating instruments with millimeter precision, and beneath the surface, an experiment so bold that it borders on the unthinkable is taking shape. The most intriguing thing: none of this is happening in absolute secrecy. It is documented, funded, authorized. But the general public, you, me, anyone, simply has no idea of the magnitude of what is being done. Maybe because it is easier to look up to the sky, searching for answers among the stars, than to admit that they may be buried. Right here, right beneath us. And this is where our journey begins, descending through dark tunnels, penetrating ancient rocks, facing colossal physical and intellectual pressures, all in an attempt to understand the origin of everything. Because after all, the largest underground construction in the world is not just a feat of engineering, it is a desperate attempt to understand why the universe chose to exist, and consequently, why we exist too. The project has a name that sounds like a common word, but carries an almost mythical weight: DUNE. The acronym stands for Deep Underground Neutrino Experiment, and although it seems like just another technical name among many others, it holds something special. A plan that involves not only physics, but also time, silence, and a dose of scientific boldness that has rarely been attempted before. It all starts with an essential question: what are neutrinos, and why do they deserve so much effort to be studied? Neutrinos are subatomic particles that are almost impossible to detect. They have no electrical charge. Their mass is incredibly small. And the most disconcerting thing: they pass through everything. You, right now, are being shot through with trillions of neutrinos from the sun, from deep space, and from nuclear reactions that are constantly occurring. And you don't even notice. None of us notice. Detecting these particles requires not only patience, but a level of sensitivity that goes beyond the normal limits of scientific instrumentation. It's like trying to hear the sound of a falling leaf in a thunderstorm. And yet, DUNE sets out to do just that. The experiment is led by one of the world's most respected institutions for particle physics. It spans 2 states, connecting 3 large underground facilities. In one of them, located near a particle accelerator, neutrinos are produced. They are launched at nearly the speed of light through the Earth's crust, without needing to tunnel or dodge obstacles. They simply pass through everything, like ghosts ignoring walls. At the other end of this 800-mile journey lies an ancient symbol of gold mining, transformed into a scientific cathedral. A mine, deep underground, where the most sensitive detector ever built will be installed. There, neutrinos will have a minimal chance of colliding with liquid argon atoms, leaving traces that can be studied. But why so much effort to observe these particles? Because neutrinos hold fundamental secrets about the universe. They can explain why there is more matter than antimatter. They can show us why something exists instead of the universe being just an absolute, sterile, silent void. DUNE is therefore more than an experiment. It is a portal, an attempt to open a crack in the wall of the unknown and peek through the other side. If neutrinos really do behave differently from antimatter, even over such long journeys, it could change the way we understand the creation of the universe. All of this happens without fanfare, without thunderous headlines, without popular commotion. But for those who know its potential, DUNE is one of the greatest scientific experiments in modern history. He is proof that even in the 21st century, there are still mysteries so great, so fundamental, that they can only be faced with silence, depth, and courage. Imagine the moment of the Big Bang, a moment in which everything, time, space, and energy, emerged from nothing. The laws of physics that we know today were still being written, and according to these laws, something strange should have happened. Matter and antimatter should have completely canceled each other out, as if each particle of matter came along with its opposite twin, collided, and disappeared. But that didn't happen. For some reason, due to some mysterious asymmetry, there was a slight imbalance. A single extra particle of matter survived for every billion particles that annihilated with antimatter. And it was from this tiny, almost imperceptible remainder that everything was formed. Planets, stars, galaxies, you, me, life. That is the paradox. The universe, according to the rules of physics itself, should not exist. But it is here. We are here. What caused this tiny but decisive difference? Where is the key that broke the perfect symmetry of nothingness? That's where neutrinos come in. These elusive particles may hold clues to this primordial imbalance. There's one intriguing hypothesis, that neutrinos and their antineutrino counterparts don't behave exactly the same way. In theory, they should. But if they don't, that could be the answer to the greatest mystery of the cosmos. Detecting this difference would require observing neutrinos in action over incredibly long distances. You'd have to create them, shoot them like arrows through the planet, and detect them on the other side with near impossible precision, which is exactly what the DUNE project is trying to do. If it turns out that neutrinos change shape or oscillate differently than antineutrinos, it could reveal the origin of the imbalance between matter and antimatter. That means, ultimately, figuring out why the universe exists, why we exist. This possibility isn't just fascinating from a scientific perspective, it's deeply philosophical. Because DUNE, with its giant caverns, freezing tanks, and sensitive detectors, is trying to answer one of humanity's oldest questions. Why is there something rather than nothing? It's not a practical question. It's not about building a faster car or a smarter cell phone. It's a search for the meaning of reality, for the origin of everything that ever was, is, or will be. The beauty of paradox is this: it doesn't need to be solved to transform us. Just the act of seeking it, of digging deep into the rock and the very fabric of the universe, connects us to something greater. It reminds us that, despite all the technology and rationality, we are still creatures who gaze silently into infinity, seeking to understand where we came from and why we are still here. Long before it was the site of one of the world's largest scientific experiments, the site where DUNE's main detector will be installed was a symbol of another human obsession: the search for gold. For decades, the Homestake mine was one of the most productive in North America. Its deep, dark tunnels held riches that transformed entire cities. But over time, the mine was decommissioned, forgotten, and closed, until someone decided that it still had value not in gold, but in answers. The abandoned structure was reopened to a radically different purpose. But transforming a historic mine into a cutting-edge laboratory is not like renovating an old house. Each step requires a highly complex engineering choreography, where any mistake could cost lives, time, or the viability of the entire project. The first challenge was dealing with the depth. The main shaft descends to about 1,500 meters below the surface. To transform this space into a stable environment, it was necessary to reinforce the structure with steel bolts, up to 6 meters long, inserted directly into the rock walls to contain the immense pressure exerted by the mountain above. Then came the excavation. The plan called for the creation of 3 gigantic interconnected caverns, 2 for the detectors and 1 for technical systems such as cooling and power supply. In total, more than 800,000 tons of rock were removed. To visualize this volume, imagine the combined weight of more than 100 Eiffel Towers being slowly removed without compromising the integrity of the surrounding space. Everything had to be transported with care. Large machines were dismantled above ground, lowered piece by piece down the narrow mine shaft, and reassembled underground. A meticulous process, repeated dozens of times, amid humidity, heat, and the constant risk of collapse. In addition, the project required respect for the mine's historical value. The external appearance had to be preserved, even as its interior was transformed into a technological fortress. This meant reinforcing without altering, modernizing without erasing, a challenge that combined tradition and innovation, civil engineering and cultural sensitivity. The weather was no help. Floods, electrical failures, logistics interrupted by storms. Each obstacle delayed the schedule and increased costs. But despite everything, the project moved forward, as if driven by an invisible force that might be the same that drives science itself. What is being done there is, in essence, impossible. Building one of the largest underground structures in the world in a remote place with limited access and extremely high risks. But perhaps that is precisely what makes it so extraordinary. Because when the goal is to understand the very fabric of the universe, nothing can be simple. Everything needs to be dug with patience, courage, and a good dose of madness. At the heart of the experiment, there is an invisible machine that crosses the Earth like a silent arrow. This machine is a neutrino beam. It originates in a particle accelerator, where protons are launched at very high speed and collide with a fixed target, producing a shower of particles that quickly transform into neutrinos. These neutrinos, unstoppable by anything, travel in a straight line for more than 1,000 kilometers until they reach their final destination: the detector installed underground in the old mine. It is important to understand there are no ducts, no empty tunnels through which the neutrinos travel. They simply pass through the Earth's crust as if it were not there. Nothing is as light, as elusive, as silent as them. What the machine does is basically create a ghost and then try to capture it in the dark. The point of origin is a few meters below the ground. That is where the PIP-II accelerator is located, a state-of-the-art technological work. The acronym hides a powerful particle propulsion system that is still under development. When fully functional, it will be able to generate neutrino beams with unprecedented intensity and precision. The goal is clear: The more neutrinos are launched, the greater the chances of detecting at least some of them at their final destination. On the other side, in the underground laboratory, everything is prepared for the miracle of detection. Tanks with liquid argon, 4 lakes controlled at extreme temperatures, function as cameras for the invisible. When a neutrino collides with an argon atom, a reaction occurs. Electrons are released, light is emitted, and the detector records everything with millimeter precision. The result is a 3-dimensional image of what was previously undetectable. But capturing this image requires more than sensors. It requires processing power. The amount of data generated by DUNE will be colossal. It is estimated that each second of operation produces volumes of information comparable to the largest data centers in the world. To deal with this, artificial intelligence technology and high-performance chips come into play. Among the highlights are specialized processors, such as the AMD Ryzen AI Pro, capable of handling up to 55 trillion operations per second. These processors don't just store and process data, they learn from it. Applications in scientific modeling, pattern detection, and event reconstruction make AI an inseparable partner of modern science. This synergy between particle physics and artificial intelligence is not a luxury. It is a necessity. Without it, the experiment would be blind. With it, it can see the invisible, interpret silence, and transform subatomic collisions into concrete knowledge. The machine of the future, therefore, has no visible gears or smoke coming out of valves. It pulses in silence between space and time, between what is and what could be. And it gives us a clue that the future of science is not only in the sky, but also buried beneath our feet, waiting to be deciphered. Science often moves in silence. There is no applause, fireworks, or headlines when the right data finally appears. Deep in the earth, surrounded by tons of rock, DUNE does not emit noises that spread. It listens. It waits. It observes what, for centuries, was considered impossible to see. The future of the project is, like everything that involves the unknown, surrounded by uncertainty. The most optimistic forecasts point to the beginning of scientific operations in 2032. Until then, the excavations, installations, and tests will continue, step by step, with the patience required by those who know that they are facing something that may not be repeated anytime soon. What is expected? To detect, over time, small variations between the behavior of neutrinos and antineutrinos. If these differences are confirmed, they will have profound implications, not only for particle physics, but for our very understanding of the origin of the universe. That is because, by finding this asymmetry, we will be able to understand why the universe favored matter, when everything indicated that it should have been nullified. In other words, why there are stars, planets, oceans, trees, cities, why there is you. But there is another possibility, that DUNE will not find these differences, that the neutrinos will behave exactly as predicted, without any surprises. Would that be a failure? Number, because the lack of confirmation is also a given. It points to new paths, rules out hypotheses, and illuminates other paths. This is how science advances. Even if the big answer doesn't come now, DUNE's structure will allow for other discoveries. It could help us understand supernova, black holes, and extremely rare cosmic interactions. It could be used for purposes we haven't even imagined yet. Because when you build something so grand, the potential is inevitably greater than any initial plan. And there is, finally, a profound beauty in all this. An old mine, once dedicated to immediate wealth, now becomes a sanctuary of knowledge. A dark cave is transformed into one of the most illuminated places in contemporary science. What was once dug for gold is now dug for meaning. There is a phrase, repeated among the scientists working on the project, that sums up this transformation well. There's more than gold in these hills. And in fact, what is being sought there cannot be measured in grams or carats. It is something lighter than air, more elusive than the wind, and perhaps more valuable than any precious metal, an explanation. Because in the end, even if DUNE doesn't give us all the answers, it reminds us of the question. And that question alone has the power to transform us. If this story made you look at the universe in a different way, if it made you feel small in the face of its immensity, but at the same time, part of something great, then watch this video now. Comment: do you believe that science will find the answer? Or is beauty precisely in the search? And if you want to continue exploring the greatest mysteries of existence with me, subscribe to the channel and activate the bell. The next video may take you even deeper or further.